A K coloring of a graph G is a vertex coloring, that is an assignment of one of K possible colors to each vertex of G such that no two adjacent vertices receive the same color. In the given graph, we observe that there are four vertices V1, V2, V3, V4. V1 is adjacent to V2, V3, V4. Similarly, V2 is adjacent to V1, V4, V3. V3 is adjacent to V2, V1, V4 and V4 is adjacent to V1, V2, V3. Each of the vertices adjacent to the other vertices. If V1 receives red color, then V2, V3, V4 should not receive red color. If V2 receives blue color, then V3 and V4 should not receive blue color. If V3 receives yellow color, then V4 should not receive yellow color. V4 received green color here. So each of the vertices received distinct color. The chromatic number of a graph G is the smallest number of colors needed to color the vertices of G so that no two adjacent vertices share the same color. The chromatic number of a graph G denoted as chi G. In the given graph, we observe that there are 5 vertices V1, V2, V3, V4, V5. V1 is adjacent to V2, V3, V4 and V5. V1 received yellow color here. So V2, V3, V4, V5 should not receive yellow color. V2 received red color here. So V3, V4 and V5 should not receive red color. V3 received green color here. V4 and V5 should not receive green color. V4 received purple color. So V5 should not receive purple color. V5 received blue color here. Each of the vertices received distinct color. Minimum number of colors required to color this graph is 5. So the chromatic number for this graph is 5. Question number 1. This graph is option A 2 vertex colorable, option B 1 vertex colorable, option C 4 vertex colorable, option D 0 vertex colorable. Here we observe that there are 5 vertices, say V1, V2, V3, V4 and V5. V2, V3, V4, V5 are adjacent to V1. So V1 should receive the color which is distinct from V2, distinct from V3, distinct from V4 and distinct from V5. Here we have dark red, red, orange, yellow, light green, green, light blue, blue, dark blue and purple colors. Now let us color V1 with red. According to the definition of graph coloring, V2, V3, V4, V5 should not receive the same color of V1, that is red. So let us color V2 with yellow. Now V3 can be yellow. Why? Because V2 and V3 are not adjacent. V4 should not be the same color of V3. So V4 should not be yellow. Let us take green. V4 and V5 are not adjacent, so V5 can be colored with green. Now see, the minimum number of colors is 3. If you look at the options, there is no 3. There are 2, 1, 4, 0. 4 is more than 3. So option C is correct answer. If a graph is k vertex colorable, then it is k plus 1 vertex colorable. Option A is the correct answer. Question number 3. G is 5 vertex colorable but not 4 vertex colorable. Then chi G is, option B is the correct answer. The smallest number for graph coloring is 5. It is not 4. Therefore, the chromatic number is 5 for this graph G. Question number 4. If the chromatic number of a graph G is M, then G is, option A is the correct answer, M colorable. It should be similar to the chromatic number or more than that, but option B, C and D are less than M. That's why option A is the correct answer. Question number 5. If a graph G has chromatic number 8, then G is 5 vertex colorable, 6 vertex colorable, 10 vertex colorable, none. The chromatic number of G is 8, and in the options, more than 8 is 10. Option C is the correct answer. Question number 6. If chi G is 6, then G is k vertex colorable, where k is less than 6, k is greater or equals to 6, k is greater than 6, none. Obviously, option B is the correct answer. K is greater or equals to 6.